Let's take a look at a couple other terms that we use in describing graphs. Those are relative maximum, relative minimum values. Now, these are pretty intuitive as well. Maximum sounds like a high, minimum sounds like a low, and that's really what they are. The one thing to keep in mind is that the actual maximum or minimum is simply the y value. It's not the whole ordered pair. Okay, it occurs at the x value, but the minimum or maximum itself is just the y value. So here's a graph, and it's going all different directions. So what I like to do is draw some vertical lines to kind of separate the sections. Anywhere there's a change in direction, I want to draw a vertical line to get distinct intervals. Okay, so then I start over on the left and I read forward and I just tell myself what's happening. Well, it's constant here, so I put a C. This next little section, it's increasing, I. Then it goes down, so D for decreasing. The next section, it goes up, so I listed it as an increasing section. Okay, so now let's see if we can answer the questions. Well, the first one is what is a relative max, and then what's the relative min? Well, the max is going to be right here at this high spot, so that's going to be the y value at that high spot, which is 1. And in parentheses, I put it's at x equals 0, but the maximum itself is the y value. Likewise, the minimum, well, that's going to be associated with this little dip here, and that's at, let's see, y equals -4. It occurs at the x equals 2, but the minimum is -4. Now, I want to point out that we don't use the endpoints because technically a maximum is where it's changing from an increasing to a decreasing. Well, this is going increasing and then it stops. It doesn't decrease. So that's not technically a maximum. Likewise over here, this A, we wouldn't use this either, or this B because it's not changing from increasing to decreasing or decreasing to increasing. It doesn't include anything that's constant or where it terminates. Okay, so what about increasing and decreasing? Well, we had two little I sections here, and remember what we want to give is the x value. So that's going from the -1, where that first red line is, to 0. And then we jump over here and we start at 2 and go up to 5. We stop there because the graph stops there. Whereas the decreasing, well, we just had that one little section. I put it in orange here. It starts at the second red line at 0 to 2. And then the only place it was constant was on that very first section that starts at -5 and goes up to the -1. All right, let's take a look at another one. Now this one is another piecewise defined function, but this one's broken. And we've talked about this before. Open circle means it's not included, it's a placeholder. Filled-in circle means it is actually the function's value. So in this particular function, f of -1, right, because that's the x value associated here, f of -1 would be 3, not 6. Okay, so it would just have one answer there. Like before, I'm going to drop vertical lines anywhere there's a change in direction. This first section again is constant, and then in between here we've got a decrease, then it goes up for a little bit, and then it comes back down. So for the max, again, we're looking for a high spot right up here. It's at the ordered pair 411, but I want to just give the y value as the maximum. That's 11. It's at x equals 4 or at 4. Likewise, for the minimum, it's related to this ordered pair 1, 2, but the minimum itself is just the 2, just the y value. It occurs at the x equals 1. Okay, increasing this time, we just have one section of increase. It goes from here to here, but I'm not reading the y values. Remember, I'm saying from what x to what x, so from the 1 to the 4. Decrease, we had two sections. The second section here, which starts at -1, goes up to +1, and then we hop over. Then again, starting at 4, and this time I'm going to go 4 to infinity. And the reason I do that is because this arrow tells me this graph goes on and on. It's not only going down, it's also going forward. So from 4, as far as I want to go forward, this graph will decrease. Constant, again, I've got a negative infinity in here because I've got an arrow. It's pointing this way. It's going to go on forever that direction. So it's constant from negative infinity until we get to -1, and then it changes. All right, I've got one more for us. Oh, sorry. Slide. So this last one. Take a look at this and see if you can answer that question. Determine the local minimum values and then all values at which it has a local minimum. All right, so minimum means I'm looking for a low spot. So it's going to be associated with this spot that it doesn't include infinities because that's not a change in direction. So it's a low spot here, it goes from decreasing to increasing. This is the ordered pair -3, 0. The minimum value is the y value. So hopefully you said 0. All values at which it has it, so at which it has it, that's going to be the x value, and that's going to be -3. Pretty easy with a little practice.